Hi boys and girls, I see a red light. Butchie Poo is on the air. My name is Butch, that's what I go by. My actual real name is Terry David Silvercloud. You can do a search of me and you'll find me. So today is the second day of November. It's a sunny day here in Vancouver, just after 2 p.m. in the afternoon. We've had a lot of rain the last day or two, but nice day. I'm 74 years old. I scorched my throat having a puff on my pipe. I smoke a lot of pot. Anyhow, I'm 74. I have severe arthritis and chronic pain, and I live alone. So to keep busy and useful, I work on my art, and I think a lot about theoretical physics kind of things, at the dark matter, dark energy, where reality gets a bit weird level of reality, right at the very fundamental level of reality. So aside from being an artist, I'm deeply into theoretical physics, and I don't script these suckers at all. I just start yakking. I can be a bit ADHD, but I'll try to make my point, and the point today is to demonstrate to you how one might think of all reality, our universe, which has to be infinite logically, is really a quantum universe and a quantum matrix, or it can be thought of that way using the concepts of quantum physics and the fundamental characteristics of a very, very solid particle called the electron. So my attempt today will be to try and explain how our reality can be viewed as a matrix, as a quantum matrix governed by electrons, all side by each, touching each other forever. And I'll get into maybe why they don't have to actually be touching. But for the point of view of this, it's not a discussion because I'm talking to you. This is all my opinion. You will want to visualize in your mind an infinite reality of spherical balls. Any old ball will do. Side by each, every single one of which are identical, I'm not sure there. And they all touch each other endlessly in all directions forever. So the thing about spheres is they may touch other spheres in 1, 2, 3, 4, 5, 6 different ways, but they do not fill a cube. Way back when Western science started thinking about these kind of things, and there's some things we don't know about from Indian culture, but from more modern concepts. Now I'm losing myself already. Where were I? Take 2. See, I drift off. I don't have a script. Let's go back a little bit, because I know I missed something, and because I missed it, that was distracting me. I will get off to this. I was explaining to you that I'm going to try and explain how you could view all of reality is cubes stacked side by each, and I was going to say the Greeks thought about that, and it was thought that you could tile, that's putting things together, blocks together where there's no space left over forever. It was thought that you could do that with a tetrahedron, but you cannot do that. But you can with a cube, and there are a number of shapes with which one could, if one had identical blocks and enough of them, you could fill all of reality forever with the exact same shape. So I'm still drifting off here. I'm going to try and explain a reality based on the concept of all of it being filled with, to start with, cubes, and then I'll divert from there and try to show you how an electron can fit into all of this, and quantum physics and all that kind of stuff. There's not going to be any really serious math involved here. This is theoretical physics, and in the last 100 years, physics, which is a study of energy, matter, and motion, science is knowledge, and a particular branch of knowledge is physics. And physics studies the relationships of energy, matter, and motion, and that's what we're doing here. So it's really been bogged down in mathematics, and that's all very nice, and it's yielded lots of interesting inventions, but there hasn't been a lot of really new thought in the past 100 years in the world of physics. Nobody wants to talk about it. Everybody's working their own secret project and hope they're the big breakthrough, whatever it might be. And now the world is different. But way back when, in the times of Sir Humphrey Davy, electricity was being invented, and my brain has temporarily forgotten the name of the guy I want to talk about here. Anyhow, there was a time when concepts were almost as important or more important than the mathematics. The mathematics could be worked out if you had a good concept. So there was a young bookbinder named Michael Faraday. It came back to me. I may forget it again. I'm ADHD. Michael Faraday was destined to be a bookbinder. That's what he was doing. He was working in a bookbinding shop, and he had, in his day, what would be not a bad education. He wasn't university educated, but, you know, like he could have been called a high school graduate. He could read and write and add, subtract, multiply, and divide. And he was a bookbinder, and apparently a nerdy type and interested in science. And Sir Humphrey Davy was coming to town, and a patron of the bookbindery where Michael Faraday worked gave Michael Faraday a ticket to a lecture by Sir Humphrey Davy. And that was a really big deal because Michael didn't have much money. He was just a bookbinder, and you know, they didn't have movies or Wi-Fi or, you know, Facebook or those things. They went electricity and light bulbs had yet to come. We're in the gaslight era here. So he went off, Michael Faraday did, to Sir Humphrey's lecture, and he made copious notes, and then he wrote them all down very nicely and bound them very nicely and sent them off to Sir Humphrey Davy. Sir Humph was so impressed, he plucked Michael Faraday out of obscurity and brought him to work for him. And at the time, electricity was new, and people had discovered that iron filings line up around wires sort of the same as they do around magnets, and they make patterns, and Sir Humph had enough to do, being the queen scientist, so he set Michael Faraday to work on see what he can come up with. And what he came up with were a lot of our basic laws of electricity. And Sir Humph got the credit for quite a while, but nowadays we know that Michael Faraday gave us all kinds of great ideas, and I guess our honor to him is naming the Faraday cage after him because he invented it. And anybody who's into physics will know what that's about, and I'm not going to tell you. I'm going to force you to look it up. No pain, no gain. If I teach you everything, I tell you everything, you'll get lazy. So where were I? So the whole point of this is that Michael was religious into a circle of friends, and he was big on more three-dimensional. He wasn't stuck with all this Newtonian, which was the only science he really knew then, of forces. Forces were there, but he got into thinking of whirly-durly forces, and he was one of the first among them. And although he didn't come up specifically, and any ideas with alternating current, because direct current was a big enough thing. Michael Faraday came up with a lot of our modern laws, and the point of all this yak is it was ideas. It was not mathematically driven. It was observationally driven. So everything I'm going to talk to you about here comes from science, I know, and we all know, and if you're a physicist, this will either all be very boring or you'll know what I'm talking about and you won't have any problem with any of the concepts I talk about. If you're not into physics, I'm not going to get into anything super complicated. I'm going to do my very best not to turn your mind into rubber, because that can happen really easily when you're talking about these kind of things. So this is all theoretical, and it's like a Michael Faraday kind of thing, looking at what I know of science and physics, and I know a lot, and I'm an artist, so I'm really into conceptualizing things, and my problems with, it's not dyslexia, but I have certain issues with the way I learn things. Once I learned them, I got them down pretty well. And I'm I'm lazy as hell. If I can get somebody else to do it for me, that'd be great. But in my old age, I'm trying to be useful, and here I am, going to give you some theoretical physics ideas based upon quantum physics concepts, based upon particle physics concepts, based upon mathematical concepts. So here we are back at, and I'm up to nearly 12 minutes already. So we've looked at the universe everywhere as being tiled with cubes. And it would be handy to imagine that the joints of all of these cubes are very flexible, and it wouldn't be hard to think of it as fish netting, except there was cube fish netting. So if a big something or other came and schmucked its way against it, it wouldn't have to break. It just might keep stretching a long way. And if the relationship between those things and the things that made this was extremely small, you could start creating curves. The physicists will understand what I'm talking about. Anyhow, getting back to the cube, the problem with the cube is that it's a cube. That may sound funny, except to the physicists. Yeah, cubes are all very lovely, and there are a couple of other shapes that will tile the universe. One of them, which I will divert here, because if I don't, I'll probably forget to talk about it, is the gyrobifastigium. And I know I did something here with it. So the gyrobifastigium, the reason I'm bringing it up right now is most of you have probably never heard of the sucker. But it's one of the Johnson solids, and I'm not going to tell you what the Johnson solids are, except to tell you Professor Johnson was from the University of Toronto, and I think I got that right. I hope I got it right. And he conceived that there were only certain numbers of solids in geometry that had certain characteristics, one of the solids being the gyrobifastigium. And I'm only going to talk about it right now so that you know what it is and what its name is. Gyro is something that can turn, and bi is there's two of them, and the rest is things that don't want to move. So you can imagine it as a pup tent, a solid pup tent, a crystal, where the sides are 1 by 1 by 1 by 1 by 1 by 1. All the sides are the value of 1. And then you take an identical one and you put it on the bottom, but you rotate it 90 degrees. So you got another pup tent identical to this one, and they're both prisms back to each. And this is the pattern. It looks a bit like a rocket ship. And 1 by 1 by 1 by 1. Did I get that right? No, I didn't. I think I wrote square root of 2 there. Don't look at that. That's supposed to be 1. Everything's a 1. That's, yeah, screwed up there. Everything's a 1. Shouldn't be there. I did this in a hurry. Anyhow, these are all 1. So if you had ones, it looks like a rocket ship, and it's an equilateral triangle, 1 1 1. square 1, 1, 1, 1. And I was thinking about something else about the square root of 2, which I'll get to maybe in a bit. So I just want you to know that the gyrobifastigium is one of the shapes that can tile the universe. And what's really interesting is you can put a much smaller gyrobifastigium into every single cube that exists. So the concept here is that not only is a sphere smaller than any given cube, because you can always fit a smaller shape. This is the problem with a cube. Even with a cube, there's a smaller shape within the cube which you can fit in there. Now, the mathematicians don't want to think of the sphere, because a sphere, by definition, has zillions of edges. And zillions of edges are very messy in mathematics, and so it's much nicer when you're getting down to shrinking down to smaller and smaller and smaller to start getting rid of as many edges as you can. But I want you to know that within this electron matrix, you can fit the gyrobifastigium, and you can fit other things. One of the things, let me see if I want to show you this one first. Let's go with this one first. There's your gyrobifastigium again. So, told you I didn't think this all out. So if you take your cube and each individual one, and you draw an X from corner to corner on every surface of your cube, you will be outlining some shapes that are smaller than the cube. They occupy less space, and some of them have fewer of these edges and pointy things, the vertices, than the cube. So if you're trying to see what the smallest sucker there is, you want it to be, it turns out, the shape of a tetrahedron. Now, if you, can you see it there? Yeah, you can. If you take our cube and you look at, here's the cube, and there's one of the, there's not an X there, I just took one of them. See, there's the cube, and there's a reason I only drew one of them, because there's two possibilities. That line you drew on one edge of the cube will represent one edge of a tetrahedron contained within the cube, and the lines on the back surface there and the other back surface over there will outline the basic tetrahedron that's contained within every cube. And it turns out, if you crisscrossed, you would see that there was two interlocking tetrahedrons within every cube, and that particular shape, where are you? You're up there. See if I can get you. Therein is your shape within. When you interlock the two tetrahedrons, you'll see on your left side of the screen, you can see at the top of the shape on your left, I think I got that right, I'm looking at my screen, you can see the X drawn on top of the box. And you can also see that there's a bunch of pyramid-y things, tetrahedrons, sitting around something, and what they are sitting around is an octahedron. So there's an octahedron. If you divvy up a cube that way, there's two possible ones, but you end up with these shapes, and within that shape you would find an octahedron. But there's another shape that is inside using those exact same lines, and that shape I'm going to show you here in a picture is this shape right there. And it may be harder for you to visualize where the lines are on the cube, but this is another shape of two interlocking triangular looking thingies that are inside every cube. And what's really interesting is what those things are surrounding is the center of every one of those is a gyro bifastigium. The pattern here doesn't look like a rocket ship because I copied the original and I saw and I realized it works just as well when you draw it looking like a rocket ship, which I prefer. So you see in my picture of a gyro bifastigium, wherever I put it, somewhere, it's here somewhere, not there, not there, not there. You can see in my pattern I made it look like a rocket ship. If you drew this pattern out one by one by ones by ones on a piece of paper and you fold them all up, it would take on this shape. It doesn't matter where you put that other pointy thing. It could be there, there, or there. It doesn't matter. So I chose to make it look like a rocket ship because symmetry is always nice. I'm an artist. Where were I? So the point I wanted to get to you about the cube is that even if you could tile the universe forever with cubes, you could, no matter how small you make that cube, you can put smaller shapes inside of it, and there's one of which can be tiled, which is a gyro bifastigium, and it sits dead at the center of the cube, and it has a shape that looks like this. So the center of this thing, which is two triangles, which have similarities. They're basically two triangles made of triangles locked as small as you can get them. The proportions will always be the same, but at the center of this shape is a gyro bifastigium. It's a triangle. It is one triangle passing through the other triangle. They pass through each other. They are doing exactly the same as a shape I'll go get. Hang on, I gotta walk across my studio here. This will be just so I can get the concept through your head. The two triangles are doing exactly the same thing as these two tori are. No matter what size you make it, if they're identical in shape, then it'll always be this way. In my reality, this is the shape of a helium molecule, but that's my view. Don't take my word for it. I have my own ideas about liquid solids and gases, which I don't have time for here. Today we're talking about the universe as a quantum universe. So I've gone on for 23 minutes, and I don't want to see how I go on and on and on. So I don't want to go on forever. So I want to get back to where were I? I want to get back to thinking about the universe being tiled with cubes, and that inside those cubes are a sphere which touches every surface of the cube. So what you'd be having is a cube, and inside the cube is a sphere. Can you see that? Maybe you can't. You get the idea? So inside every cube there's a sphere that exactly touches all the surfaces of the cube, all 6 of them, and it can't go anywhere unless another cube gets out of the way. But inside the cube it's free to spin, and I'm suggesting to you it does. And if you want to think of this as being an electron, which I'm asking you to do, for the sake of motion, thinking of the electron as a sphere There's nothing wrong with that. It's not really quite the right proportions here. So there's nothing wrong for the sake of visualization of thinking of an electron as a sphere. And what we know about electrons is they're all identical. As best we can tell, every single one is the same. They appear to be indestructible, but we can make gamma rays appear if we smash those electrons hard enough against certain materials. And I'm suggesting, this is me, that electrons are composed of 20 smaller particles which are identical, all of which are tetrahedrons. And what makes the sphere complicated is tetrahedrons cannot, I missed something there. Let's go backwards here. What's inside of here is, so I said tetrahedron. What's inside of here is an icosahedron, which is I think I probably said that. See, I'm ADHD. So the shape of the electron, I want you to think of it, this is my idea, is an icosahedron, which is 20 tetrahedrons, all with a common apex. It's basically the shape of the explosion area of all nuclear bombs. They fire all the fissionable materials, and that's the most efficient way to fire up to 20 different bits of fissionable materials at the same target at the same time, is to make the shape an icosahedron. So everybody does it, it's no secret. You can check. See how I divert? So I would like you to think of electrons as being icosahedrons, and that unless you can come up with enough energy to break those 20 tetrahedrons apart, you can't, and every single electron will be identical, made of 20 identical tetrahedral particles, which I like to call the gamma. I think they're responsible for gamma rays personally. I think the particles which, this is my personal opinion, that the particles which compose an electron, once they're together, are extremely stable. And that's because they're resisting the pressures of gravity. I believe gravity is push, not pull. And even if you think it's pull, they're pulling each other together at a common apex. All 20 apexes are at a common point of the 20 tetrahedrons that form an icosahedron. So you got to imagine the universe filled, and anyhow, when you get the icosahedron spinning, for all intents and purposes, it is a sphere. You might as well think of it as a sphere once it gets going, because it'd be like a jeweler's bit. You don't want to be in the way of anything going by. You're going to get clipped for sure. And something that's interesting about the icosahedron is if you truncate it, which is if you slice off all the star-shapy parts, you get what's called a truncated icosahedron, and you can come up with a way of tiling space forever with that. That's just an aside. Where were I? So let's get back to thinking about each cube as being only one electron. Now, the value for an electron has mass. You can measure its mass electronically. It has a electronic motion mass in quantum physics. Or you can measure it as part of a coulomb. A coulomb is, by definition, is a given number of electrons. And so there are a number of ways in which you can measure the space partaking characteristics of an electron. It takes up space, and that's the whole thing. You cannot have more than one electron in one place at one time, but an electron can absorb a unit of energy, one quantum of energy, which can also be described as a photon, and they can occupy the same space at the same time, because a photon or a quantum is not a solid unit of particleness. It is a wave unit of energy occupying the same reality as the solid stuff. So if an electron were sitting still out there in space with nothing to do, not moving at all, and a photon of energy struck it, it ain't going nowhere. It'll just spin until it wears out that photon's worth of energy, which it'll probably do in one complete turn, and it's done. That energy was used up in making one spin of the electron. So one could then deduce that frequency is nothing more than counting the spins of an electron. And if you think of an electron as being a magnet, for every turn it makes, it turns another sphere. Doesn't even matter if they're the same size in this case. That would just be a gear ratio. But if an electron were to turn another sphere at the same rate as it turned, if they were the same size in this case, it would just be really passing its energy on to the 6 surfaces around it, and it would deplete that really quickly. Now it would deplete it less on its poles because they would spin the least. It would depend on the direction the spin was coming from. I think the physicists got that. Where were I? So I want you to start thinking of the universe as being filled with electrons, all side by each forever. And if one makes any spin, the next one to it must spin. And even if there's not an electron there, the volume of space between it and the next available electron has exactly the same cubic energy qualities, quantum qualities, as the next cube. This may not go down well with some people describing a quantum as filling a cube, and we know it doesn't, but it's just easier to think about it as one quantum per cube. That way, the whole universe can be divvied up into either one quantum spheres touching each other with something in between, which in its own reality is a gas or a fluid, whatever you want. There's no emptiness anywhere, really. It's just space taking shapes. And the most stable shape of shapes is a tetrahedron, and the smallest tetrahedron is an equilateral tetrahedron. And if you get 20 equilateral tetrahedrons together, you got yourself a fairly formidable tiny force, where 20 tetrahedrons acting together, they ain't going nowhere unless you can spin them. And to actually move them, you're not going to move them very far. They're just going to push against the fishnet cubic reality around you. And the transfer of energy is always going to be in quantum units. If it gets pushed with 5 quantum units, it's going to resist with 5 quantum units and dissipate that energy primarily in the direction of the force hitting it. This brings us to the speed of light. Nothing can move from here to there without the help of an electron, and I want to get it into your mind that the very smallest unit of any consequence to we electronic beings who cannot hear, see, touch, smell, did I miss any? Anything without the help of an electron transmitting that information up to the old stoned out person behind the control screen up there. Warp speed, let's go. I'm up to 33 minutes, and I didn't know how long I jack on. I don't know if I made my point. But the real point here is, if you think of the entire universe being tiled forever with side by each spheres known as the electron, you can think of the electron setting all of reality, because it will be the dominant shape within the cube. So the total energy value may be dissipated over the, through Pascal's law theory. The pressures may be distributed equally, but when you get down to the center of the cube, it's easier to think of the forces dynamically going out in all directions and having the most impact on the where the sphere is touching the edges of the cube, because that makes it easy to think of it all as a wave. Pretty easy, waves, nice and curvy, perfect curves. Your perfect wave with your perfect balls. That wasn't meant to be dirty. I got a dirty mind. Where were I? I'm up to 35 minutes ago. I'm going to shut up. I hope some of this made some sense. I want you to think of the universe as being wall-to-wall electrons, and even though they're wall-to-wall, we have no trouble punching our way through electrons. Do you want to see me punch my way through zillions and zillions and zillions of electrons? Watch, I'm going to do it. Are you ready? I'm going to punch my way through gazillions of electrons. There, I just did it. Piece of poop, right? Nothing to it. So it depends on how the electrons are organized. Now, if they got themselves really organized and built up a structure this big, now it has some problems. So if a standing wave of electrons got in the way, I might say ouchie ouch, but the electrons, the ball of electrons would still respond, and I can't be 100% sure. Actually, in my own mind, I say it just goes straight on through the quantum matrix. The solid stuff behaves following the laws of flotation and buoyancy, where there is no up or down, where up or down is always decided by what the greater spin is around you. The greater spin around you right now is the spin of the Earth. That's what's holding you down towards the floor, is the Earth spinning in space. And the point of most rest on Earth right now is dead center, at the center of Earth. So now I'm straying, and hope I've got you interested in this kind of stuff, but I can't go on here forever, even though I yak on and on forever, and I don't know if I made my point. Just want you to think of, it's easy to think of quantifying the universe with electrons. Quantum physics does it every single day. You physicists will understand what I talk about. We quantify the electron every single day. And if you start thinking of it being like the platinum rod that measured the meter in Paris, I made another video, I called it a yard, but that's just my brain tripping over itself. The measure of our reality is the solid particle, the electron. And if you think of the electron having its own cube of space, and that the stuff left around is just the smaller riff-raff that makes up that sucker, reality comes a lot easier to calculate. So Butchie Poo is going to shut up. I'm not wacko, you know. They had me tested. Sometimes it's hard to explain these things. It can turn your mind to rubber. So I'm up to 38 minutes. If you're still here, I hope you enjoyed it. I'm going to put my cursor onto the, if I can find it, there it is, on the red button. And 5, 4, 3, 2, 1, bye-bye.